Hi, my name is Ankita Adhvaryu, and this is my experiment. Tens of thousands of seabirds suffer from the effects of plastic pollution every year. For years, it was believed that marine animals ingest plastic because they mistake floating debris for their natural prey. However, a recent study suggests that seabirds are attracted not only to the sight of plastic, but also to the odor. This is due to the fact that plastics in the ocean serve as the perfect substrate for algal growth, and this algal growth emits the chemical dimethyl sulfide. Seabirds are immediately attracted to this chemical, and they often consume the plastic substrate in their effort to consume zooplankton, their natural prey. By determining which environmentally friendly algae deterrent is the most effective, the research findings can be applied to deter algae from growing on plastic substrate. As a result, seabirds will have a lesser chance of being attracted to algae-laden plastic and accidentally feeding on them. The experiment attempted to determine which environmentally friendly algae deterrent would be the most effective in preventing algal growth on plastic substrates. The research findings would aid in the application of a temporary method to prevent the deaths of seabirds until a more permanent solution is found to the global plastic pollution crisis. First, 100 petri dishes were split into 4 equal groups of 25. Each of the petri dishes groups were designated by letters B, C, H, and S, respectively. All the petri dishes were filled with 15 milliliters of simulated ocean water, and a 4x4 centimeter white PVC plastic square was placed in each. 4 milliliters of live marine phytoplankton was added to each petri dish and allowed to grow undisturbed for the next 14 days under natural sunlight and at room temperature. After the growth period, a picture was taken of each petri dish. 3 milliliters of 0.1 molar barley straw extract was added to petri dishes marked B. Similarly, 3 milliliters of 0.1 molar hydrogen peroxide and 3 milliliters of 0.1 molar sodium bromide was added to dishes marked H and S respectively. The dishes with the C were left alone to serve as the control. After 5 days, the dishes were photographed again and all the pictures were digitally processed. A 40 by 40 grid was then used to quantify algae coverage on the substrate. The values were then used to determine percent change in algal growth over time. These numbers were then recorded in the table, and the data was used in order to create a graph and run t-tests. Based off of previous research, it was hypothesized that if different types of environmentally friendly algae deterrents are applied to a plastic substrate, then hydrogen peroxide will diminish the growth of algae the most. The experiment demonstrated that hydrogen peroxide shows the greatest inhibitory effect on the growth of algae compared to sodium bromide solution, barley straw extract, and the control, therefore supporting the hypothesis. The smallest difference was found to exist between the sodium bromide solution and the control, suggesting that sodium bromide solution was the substance with the least effect on the diminishment of algae. The standard deviation was relatively low for most of the 4 levels, implying that the data was precise and had little variation. The same applied to the variances produced. Out of the 100 total trials, there were only 4 points that fell outside of the 2SD range, meaning that there were only 4 outliers. The 6 t-tests performed between the levels show that the data was overall statistically significant, and as a result, the null hypothesis was rejected. The findings showed that the hydrogen peroxide solution was the most effective deterrent out of all those tested, followed by barley straw extract and finally sodium bromide solution. Previous research has shown that dissolved oxygen creates an unfavorable environment for algae growth. Due to this, hydrogen peroxide is an effective deterrent since it decomposes into water and oxygen, creating an excess of dissolved oxygen in the water. The ineffectiveness of the sodium bromide solution was most likely due to the fact that sodium bromide is often used in conjunction with chlorine, as their combination forms hyperbromous acid, a potent algicide. Without chlorine, the sodium bromide solution was unable to reach its full potential. The research hypothesis was supported by the data overall. The data in general implied that the results were not due to chance or error, showing that the independent variable did have an effect on the growth of algae. Nevertheless, despite all this, barley straw extract was the most ideal and effective deterrent tested. While scientists still have not determined the chemicals responsible for its algae-static behavior, barley straw extract is still the least likely to cause any type of environmental harm due to its being entirely natural. But, as always, there was room for improvement. The experimental procedure could have been improved by controlling the light source, since as the day progressed, each petri dish may have received varying amounts of sunlight. This could be done by placing the petri dishes under an artificial source of light, like a grow light. Research on this topic is still ongoing, and scientists predict that dimethyl sulfide might not just affect birds, but also fish and a wide variety of other marine animals. In the future, hopefully the premise of this investigation can be applied to help decrease the negative consequences of plastic pollution on our Earth's marine ecosystems.